What we're going to talk about today is how to take an engineering design, in this particular case it's representing an LED-based street lamp, and turn that into a device appropriate for doing an illumination simulation so you can determine whether or not the device meets the design performance specifications. What we have here, again, is a model for an LED street lamp, and we see the full geometry, if you will. We see the mechanical structures. We see the front and the rear block, as well as the top area where we would conceal the electrical wiring and other information. And if I rotate around a little bit, it's hard to see simply because it's transparent, but we have our glass cover plate, which is largely used to keep the external environment from interfering with the light itself, but it also can have diffusing properties applied to it to help improve the light output distribution. And inside that, you'll see a series of reflecting cavities. If we rotate around a little bit and zoom on in, and you'll see that at the base of each of these reflecting cavities is a geometrically and radiometrically accurate representation of an LED model. The LED model comes from the source library that's included within Apex, and we'll talk a little bit more about that later. But let me zoom out just a little bit, and let's take another look at the geometry, but we'll expand it a little bit so we can talk about the different components in a little more detail. And again, here we can see the mechanical structure, the blocks. You can see in our top plate we've included the cooling fins necessary for our LED design. Then down here we have our sources, which basically consists of a printed circuit board, and then arrayed across that printed circuit board are our LED models, and then our reflecting cavity. If we zoom out a little bit, we can now see the glass cover plate as well. So all of these items together make up the mechanical and, in some parts, the optical structure of our LED. Now what we want to do is talk about how we would turn this into an actual illumination system. And for this to become an illumination or an optical system, the important thing for us to do is to apply the appropriate optical properties. To take a look at that, I'm going to come over here into the Optics Manager within Apex. And this is the part of Apex where we can see the information that is available as well as to apply that information. You'll notice we have several optical libraries available to us. The lenses are not relevant in this particular example. But we also have a media catalog, which has information about the dispersion and refractive indices of a wide range of materials. We also could apply thin film coatings or idealize reflecting or transmitting coatings to surfaces. We also have information about measured data for roughness or texture standards that are often applied to illumination devices. Many illumination systems, rather than having perfectly smooth and shiny reflecting surfaces, we actually apply a texturization to that to diffuse the light to give a more pleasant output to the radiation pattern. And that information is available in the scatter model library. And we also have a library of sources. And we're going to be looking at several of those as we proceed with discussing this example. But the first thing we want to think about is not what we need to consider when we do our illumination analysis, our ray tracing, if you will. The first thing to think about is what we don't need to worry about. And if we look at this design, and let me rotate it around a little bit, our LEDs are located on our printed circuit board, and the light leaves the LEDs and goes through the reflecting cavities before exiting out the output face through the plate glass. You'll notice that the light cannot interact with the block geometry. So in order to speed up our calculations, one of the things we can do in Apex is to select these items of geometry right here. And what I'm going to do is by right-clicking, I can get a little flyout menu, and one of the options available to me is Ignore. And if I select Ignore, what you'll notice is these items are now grayed out in the manager tree, but they are still visible within the graphic window. This is very important. I could have done the same thing by hiding or preferably suppressing within the CAD environment, but then I'm not able to see the entire geometry. It's very useful for me to be able to visualize my entire illumination device while I'm doing my analysis, but I don't want to have to worry about the computational engine querying all of this geometry to see whether or not the rays interacted with them, because we know a priori that they don't. So this is simply going to speed up my ray tracing calculation, and as an engineer, what I want to do is to do the most efficient analysis I can. Now let's take a look at some of the other components. In particular, let's zoom in on the source again, which is again the PC board with all of the arrayed LEDs. The LEDs come from the light source library that is included within Apex. There are a wide range of LEDs from many manufacturers available, and these are both radiometrically as well as geometrically accurate representations. In other words, you will see a model of the geometry to accurate size so you can position it correctly within your design, but you will also be able to trace rays that represent both the area and angular distribution of the light that comes from any of these sources. And in addition to LEDs, there are also a large number of filament bulbs, commonly used in automotive illumination applications. There are also some CCFL and arc lamp designs as well. If we open up the source item right here, what you'll notice is I brought in one copy of that LED, and then using the array capabilities of the CAD environment, I simply made a sufficient number of copies of them to fill out my 7x7 array of LEDs. And let me click that down a little bit. And let's zoom out again. Next item we'll talk about is the reflector. And here's our reflector here. And again, it's an arrayed series of little cavities, in this case, simple flat face cavities, which of course would modify for the true design. Now, if I expand out the information on the reflector, you'll see that I've put a perfectly reflecting coating on that surface. But again, in reality, typically these surfaces would be slightly diffused to give a better distribution of energy. And what I'm going to do is simply, again, right-click on the reflector so we can get this fly-out menu one more time. It's the same one we used previously to ignore some of the prior geometry. But this also allows us to get access to many of the catalogs or libraries included within Apex, in particular the roughness model or scatter model directories. Let me select roughness model so we can take a look at it. And since this is a reflector, I'm only going to worry about scattering the reflected rays. But if I click on select, what this does is it opens my scatter manager area. And within the scatter manager are a wide variety of commercial textures that have been measured and modeled mathematically for use within Apex. You can also add your own models or create your own models as well. But in this particular case, if I assumed this was a nice reflecting surface, I might come into one of the commercial texture standards that are available and select a material and simply choose to apply it and click on OK. And now you'll notice that we now have a roughness model applied to each of the faces of the reflector. And I'm going to hide those faces for now because we don't really need to see those. We could also have only selected these particular faces to apply the roughness to, but in this case, I applied it to the whole surface. Okay. The other piece of information we need to apply deals with the front cover. In this case, the front cover is largely glass. In this case, we have a transparent region. We also have the structure that holds it in place. So what I want to do with the glass cover is to apply a refractive property to it. And you'll notice I have some part of the area that I'm going to make perfectly absorbing, the black regions here. The rest of the geometry will have this refractive property. Another nice thing we can do within the Apex environment is you'll notice this little indicator of ignoring reflected rays. Because this is a glass cover plate, when the light from the LED passes through the reflecting cavity and hits this surface, some of the light, some of the energy, will get reflected back due to Fresnel reflections. In this particular case, we're not really concerned with what happens to those rays after they rattle around within the cavity a couple of times. So what we can do is choose to ignore those rays. So when we look at the visualization, we won't see those rays, but the fact that energy was lost when the light traveled through the plate will be taken into account. Now, I will be perfectly honest, the main reason I'm doing it in this simulation is it's going to give a much more visually appealing picture at the end. So again, that's a look at most of the information. One other thing just to mention is when we do our ray tracing, which will be about the next step, let me open up the sources one more time, and you'll notice in addition to arraying several models of the LED, the 7x7 array, associated with each of those is a ray set file, a data file, that has this radiometrically accurate ray distribution. This is created also directly within the light source library within Apex, so you don't need to go up to a manufacturer's website and get a particular ray set. You can generate them in real time within Apex and then store that information and reuse it. So as you do a simulation that requires a very large number of rays, you can just generate those within the Apex environment. You don't need to find them from an external source. So that's a little bit about applying optical properties. And now what we'll do is look at a ray trace, the results of a ray trace. And what I'm going to do first, so we can look at it in more realistic visualization mode, is I'm going to put the whole design back together and zoom out so we can see it a little bit. And I've already done a ray trace. So what I'm going to do is load up that information. And what we did when we did the ray trace is all of those data files were launched from the LEDs. They then went through the reflecting cavities and out the output face of the lamp. We could have defined a wall or a floor surface to do the analysis, but in this particular case we didn't. We're just going to look at the output distribution as the rays sit on the output face of the cover plate. That's a little difficult to look at, so what I'm going to do right now is to come over here and just change the ray color very quickly. Just come down here, just so we can see them a little bit better. They do appear to be fading into the background here. So what we see is from each of the LEDs going through the cavities, we see the ray distributions. Only a small number of the rays are being visualized, although for analysis we will look at all of them. And then under analysis, what I've done is an intensity calculation in direction cosine space, and what we're looking at is a contour distribution of that information. We can also look at it in a false color scale, and obviously we need to do a little bit more, add some more rays, and probably perform some other analysis, including modifying this data to do some simple statistical averaging, which I can do simply by clicking that right there. And now we can take a look at another contour plot in either 2D or 3D. So let's bring it back down to 2D. So after we do a little bit of statistical averaging, we can get a little bit more information from the analysis. You'll also notice we could do irradiance type calculations, and there are many ways of looking at visualizations of that data within the Apex environment. So now let me go back to a model view. So in summary, what we've looked at today is how to take our engineering drawing, turn that into a design that has the necessary information to perform a ray tracing, and then we've done some ray tracing and analysis on the design. Also remember that there are the tools available to you, such as the ignore, either to ignore geometry or ignore particular ray directions, that can allow you to speed up your analysis without in any way affecting the accuracy of it.